Today we're going to talk about titrations. Now we're going to get into more detail about titrations in Unit 8, but this is just a starter because titrations can be very useful and you should know about them. So let's give an overview. Titration is a procedure that can be helpful to determine the concentration of a reactant that you're using in a chemical reaction if the concentration of that reactant is unknown. We use titration in studying acid-base reactions, oxidation-reduction reactions, also called redox, and precipitation reactions, so they really do come in handy. Let's start by going over the titration apparatus and talking about some important vocabulary. The typical setup for a titration is shown in this picture. A burette is a very accurate measuring device that allows you to slowly drip in small volumes of a reactant drop by drop, and this gives you very, very exact measurements. That little stopcock on the bottom of the burette is how you control the amount that you drip in. One of the quirky things about burettes is that you read them upside down. That means the markings on the burette tell you how much solution has been dispensed, how much has dripped out of the burette, and not how much remains in the burette. So in a sense, this is the opposite of the way we read a graduated cylinder. When you fill the burette, you fill it all the way to the top up to the zero line. In order to read it before or after the titration, you have to make sure that you're looking at it from the side, and so that the bottom of the meniscus is at eye level. You don't want to look at it from above or below, or your measurements could be very far off, and they need to be as exact as we can get them for titration. When you read a burette, you read the bottom of the meniscus like you usually do, but you have to be aware that the numbers increase as you go from top to bottom. So for example, the line for 21.5 milliliters is going to be below the line for 21 milliliters and not above it. We call the reagent that you put into the burette the titrant, and the titrant typically has a known concentration that we choose. Under the tip of the burette, where we are dripping the titrant out, we typically put an Erlenmeyer flask with a reagent in it that has an unknown concentration. We call this reagent the analyte, or sometimes the titrand. Sometimes you'll put the flask on a plate with a magnetic stirring rod, and this can be very handy. So let's talk about how to do a titration. When we do a titration, we slowly drip titrant into the analyte flask until we get an indication that both of the reactants have completely reacted with each other. In other words, the analyte has totally been consumed by the reacting species in the titrant. We can then use volumes and stoichiometry to determine what the concentration of our analyte, which is unknown, is. How do we know when the reactants have completely reacted? Well, if we're doing an acid-base titration, we can use a pH indicator, a substance that changes color when a solution reaches a certain pH. We can also use a pH meter to plot a titration curve, and we'll talk about this in a minute. For redox reactions, we can use a redox indicator, and this is a substance that changes color when the oxidation state of a particular metal ion changes, and we'll talk about redox reactions in a couple of days. For precipitation reactions, the indicator that the reaction has taken place is the actual precipitate. The reaction is considered to be complete when no more precipitate is made. We will often use the term endpoint to describe the point during a titration where the indicator changes color. Once we know we're at the end point and that all of the analyte has been consumed, we can read the burette to determine how much titrant was needed to get to the end point and to consume the reactant. We use this volume for our stoichiometry calculations. If you have the right equipment, such as a pH meter, you can make a titration curve and use it to determine the amount of titrant needed to completely react with the analyte. This can be a little bit more precise than just using a pH indicator. Titration curves are often used in acid-base reactions, and you will be using a lot of these in Unit 8. Let's talk about how to interpret one of these curves. We're going to use an acid-base titration curve as our example. At point 1, the only thing in our flask is the analyte that we are analyzing. This is going to have a certain pH depending on whether it's an acid or base, or depending on whether the acid or base is strong or weak and how concentrated it is. We take our burette and we start dripping in titrant. Between points 1 and 2, all of the titrant that is being added is reacting with the analyte. The analyte is the excess reagent. We keep going, and eventually the titration curve will start to get very steep as the pH starts to shoot up. This is between points 2 and 3. Point 3, the equivalence point, is the point in the center of the curve. This indicates the volume where the two reactions have reacted completely and where there's no excess or limiting reactant. If you drop a line down from the equivalence point to the x-axis, you can get the concentration of the titrant that was added from the burette. This is the concentration you'll use for your stoichiometric calculations. Once you go past the equivalence point, you're just adding excess reactant. No more reaction is occurring. One of the reasons that making a titration curve is a little more accurate than using an indicator is that the endpoint is generally a little past the equivalence point. It's also sometimes challenging to tell exactly when the indicator is changing color, especially if you accidentally drip the titrant too quickly. So let's summarize. Titrations can be used to determine the concentration of an analyte in solution. The titrant has a known concentration of a species that reacts specifically and quantitatively with the analyte. The equivalence point of the titration occurs when the analyte is totally consumed by the reacting species in the titrant. The equivalence point is often indicated by a change in a property, such as color or precipitation, that occurs when the equivalence point is reached. The observable event is called the endpoint of the titration.